Open the Catalog tab. In your GIS class folder and your MGIS data folder, find the Austin folder. Right-click it and choose New File Geodatabase. When it appears, give it the name Edwards and click Enter. Now open ARC Toolbox. Expand the Data Management tools and the Feature Class tools, and double-click on the Create Feature Class tool. For the Feature Class location, click the Browse button. Navigate up to the MGIS data folder and into the Austin folder. Select the Edwards Geodatabase and click Add. In the Feature Class name box, type Karst Features. Set the geometry type to Point. Leave the template Feature Class blank. Scroll down if necessary to locate the Coordinate System box. Click the Browse button. Click the Add Coordinate System drop-down button and choose Import. Navigate to the Austin Geodatabase and double-click it to go inside. Select the Environmental Feature Dataset to copy the coordinate system from it and click Add. Notice that it's set to NAD83 State Plane Texas Central. Click the newly added coordinate system to highlight it and click the Favorites button to add it to the Favorites list. Click OK to close the coordinate system window and OK to finish creating Karst features. Open ARC Toolbox and double-click the Create Feature Class tool. Click the Browse button, navigate up one, and set the database to Edwards. Click Add. Name the feature class False. Change the geometry type to Polyline. Scroll down and click the Coordinate System Browse button. Select the Texas Central State Plane Coordinate System and click OK. Click OK to finish creating the feature class. Open ARC Toolbox and double-click the Create Feature Class tool. Click the Browse button for the feature class location and set it to the Edwards Geodatabase. Name the feature class Geology. Leave it set to Polygon. Scroll down and click the Coordinate System Browse button. Select the Texas State Plane Central Coordinate System and click OK. Click OK to create the feature class. Open the Catalog tab. Find the Edwards Geodatabase and expand it. Right-click the False feature class and choose Properties. Click on the Fields tab. Click inside the first empty field name box and type line type to name the field. Click inside the Data Type box and choose Text for the data type. Under the field properties, change the length from 50 to 10. Click OK. Open the Catalog tab. Right-click the Geology feature class and choose Properties. Click on the Fields tab. Click in the first empty box and name the field Unit. Set the data type to Text and set the length to 6. Click OK. Open the Catalog tab. Right-click the Karst Features feature class and choose Properties. Click on the Fields tab. In the first available box, click inside it and enter the name Type. Set the type to text and set the length to 15. Click OK. Find the group of springs in the lower left corner of the map. You may need to zoom out a little bit to see them. Click on the Zoom In tool and zoom in around those springs. Click on the Karst Features template. Click inside one of the blue dots to add a point. Continue adding points inside the blue dots until you have digitized all 6 springs. Notice that the last one remains highlighted, indicating that it's still selected. Click the Delete key. The points you added will go away. Click on the spring again to re-enter the point. If the Editor toolbar is not already out, click the Editor button. From the Editor toolbar, choose Editor, Start Editing. Select the Edwards Geodatabase from the lower part of the window and click OK. Choose Editor, Editing Windows, Create Features. If necessary, dock the Create Features window on the right side of the window. Click on the Karst Features template. It shows several different construction tools. Then click on the Geology template. It shows a longer list of tools. Right-click the Karst Features layer in the table of contents and choose Open Attribute Table. The last selected point is still highlighted in the table. Click in the Type box and type the value spring. Click in the next box up and type spring also. Instead of continuing to add them all by hand, highlight the next row up by clicking in the gray box to the left. Click the Attributes button on the Editor toolbar. The Attributes window may appear as a window, or it may appear as a tab in another window. The top panel of the Attributes window has the currently selected feature, labeled with its object ID. In the lower panel, you will see the Type field. Click in the box that currently says Null and type Spring. Click Tab to enter the value and watch it update in the table window. Click and drag the bar of the Attributes window to the table of contents and dock it on the lower half. You can use the line in between them to adjust the relative size. Make sure that you can see both the Attributes window and the table window. Choose the Edit tool from the Editor toolbar. Click and drag a rectangle around all of the springs to select them. The Attributes window now shows them all. Click on the Karst Features heading at the top of the list of selected features. Type Spring in the field at the bottom. When you click Tab, the value will be entered in all rows of the table. Right-click one of the feature rows in the Attributes window and examine the context menu with the various options, such as flashing, zooming to a feature, selecting it, etc. When you're done, click on the top bar to put the menu away. Close the table window. On the Editor toolbar, choose Editor, Save Edits. Clear the selected features using the usual button on the standard toolbar. Find the fault that travels diagonally across the map and cuts through one of the springs. Use the Zoom and Pan tools to adjust the view so that you can see the entire length of this fault from bottom to top. Then click on the Faults template. Notice that Line is the default construction tool. Click on the lower end of the solid part of the line to start entering the fault. Ignore the little toolbar that appears and click your way up the line, adding a vertex every so often until you reach the end of the solid portion. Double-click there to end the line and complete the sketch. The highlighted line feature appears. In the Attributes window, click in the Line Type box for the selected fault and enter Solid. Click Tab. Move the cursor to the lower end of the fault that you just added and notice the snap tips that appear. Move it up and down the fault and see how they change. Then place the cursor at the lower end of the fault, making sure that fault's endpoint is being displayed. Click to enter the first vertex of the new fault. Add several more along the line, and then double-click to end it when it reaches the other fault. Click in the Line Type box in the Attributes window and type dashed. Press Tab. Click on the fault symbol to open the symbol selector. Give it a thick 2-point line and make it green. Click OK. Click on the Faults template. Snap to the end point of the existing fault and click to add the first vertex. Add the remaining vertices and double-click to finish the sketch. Click in the Attributes window and enter dashed for the line type. Press Enter. Zoom to the full extent of the map. Find some black dots representing springs in this area. Click the Zoom In tool and zoom into them. You should see 5 black dots in the pink and blue and the brown area. Click on the Karst Features template. Add a point inside each of the black dots. Click on the Edit tool on the Editor toolbar and draw a box around all 5 of them. They're now selected in the Attributes window. Highlight the top Karst Features entry and in the Type box type cave-sync. Click Tab to enter the values. For a little more practice, click on the Faults template. Digitize 2 or 3 of the small dashed faults in this view. For each one, remember to enter the line type as dashed. Click to start it, click to enter each vertex, and double-click to end. Always remember to type dashed. When you're finished, choose Editor, Save Edits from the Editor toolbar. Also click the Save button on the standard toolbar to save the map document. From the Editor toolbar, choose Editor, Snapping, Options. Make sure that the snap tolerance is set to 10 pixels. Examine the snap tips checkboxes, which control the snapping guides or text that appear as you try to edit. Click OK. Choose Editor, Snapping Toolbar. It appears next to the editor window. This controls individual types of snapping as you're working. Choose Snapping from the Snapping toolbar and examine the menu choices. Click and drag the handle of the Snapping toolbar or its title bar so that you can dock it in a convenient place where it's easily accessible. Then look above the KPRD text and find the short dashed blue fault. Click on the faults template. Start at the upper end of the fault and digitize down until you get to the end. Double-click to finish the sketch. Enter dashed for the line type in the Attributes window. On the Snapping toolbar, click on the Edge Snapping to turn it off and the Vertex Snapping to turn it off also. These are toggle switches. Begin the next section of the fault by clicking on the Faults template. However, it's trying to snap to the spring point also. So also turn off point snapping. Click to snap to the end point of the fault and begin to digitize. Snap to the end of any existing faults that happen to be along the way. When you get to the edge of the map, don't stop yet. Switch to the Pan tool and move the map image so that you can see all the way to the edge. Go back to your fault template and continue the sketch. When you get to the end, double-click to finish the line. Click in the line type box and enter solid for the attribute. With the faults template, click on the edge of the image to start the next fault below. Enter vertices as you move up the fault. When you run out of map, switch to the Pan tool and move the map so that you can see the continuation of the fault. Switch back to the template and continue entering points. Keep going until you hit the place where it splits into two by the caves. Double-click to finish the sketch and type solid for the line type. Click the Tab key. Click the Faults template again and start a new fault snapping to the end of the old one. Take the upper branch and continue adding points all the way up through the solid part of the fault. When you run out of map, switch to the Pan tool and pan again. Then switch back to the template and continue adding points. Keep going until you get to the location where the fault splits in two again by the text Buddha. Double-click to finish the sketch and type solid in for the line type. Click Tab. Click the Pan tool and look to the north and northeast of Buddha. You will see additional springs and caves. Change to the Karst Features template and click inside the blue circles to add the springs. Use the Edit tool to select them all. In the Attribute Editor, click on the Karst Features entry and assign them all the attribute Spring. Click Tab. North of the Buddha text, find the black circles. Click the Karst Features template and enter them all. When you're finished, click the Edit tool and select all of them. Click in the Attributes window and type Cave Sink for the attribute. Click Tab. Choose Editor, Save Edits, and then click the Clear button to clear the selected features. Zoom to the full extent of the map. Find a clear area and click the Zoom In tool and zoom into it. This next editing is just for practice. Click on the False template. Enter some vertices along a random line. Notice that the last vertex is red and the other vertices are green. Right-click on top of the last red vertex to open the Vertex menu. Choose Finish Sketch. Start another line and add some more vertices. Right-click on the last red vertex and choose Delete Vertex. It disappears and now the previous one is red. Right-click any of the green vertices and choose Delete Vertex. That vertex will disappear. Right-click another vertex and examine the menu again. To get rid of the menu without choosing anything, click on the window bar at the top. Notice that all this time we are still in the middle of creating this sketch. Now right-click on the sketch in between two vertices. Choose Insert Vertex, and a vertex will appear where you clicked. Right-click another segment of the sketch between two vertices. A different menu appears if you click off the sketch. Click on the window bar to make the sketch menu go away, and right-click off the sketch somewhere on the map. The longer Sketch menu appears. Some of the entries are the same and others are different. Choose Delete Sketch from the menu. Start a new sketch with several vertices. Right-click off the sketch to open the Sketch menu and choose the second entry, Direction. A box will appear. Type 90 in the box and press Enter. Notice that now the cursor is constrained along a vertical line. Click to enter the next vertex, and the new segment is exactly vertical. Double-click to finish the sketch. Start another sketch and add several vertices. Right-click off the sketch and choose Length from the Sketch menu. Type 5,000 in the box and press Enter. Now the cursor is constrained along a circle exactly 5,000 meters from the previous segment. Click somewhere to enter the vertex. If yours did not go very far or went too far, try changing the amount that you typed in the box next time. You are still in the middle of this sketch. Right-click off the sketch and choose Direction Length. Enter 45 for the direction and 5,000 or an alternate number for the length. Press Enter after you have them both entered. Notice that you didn't even have to enter a vertex. It was automatically placed at the correct angle and distance. Double-click now to finish the sketch. Click on the Edit tool. Draw a box that goes through the lines that you've created. To select them, and press the Delete key. Click on the Geology template. The Polygon Construction tool is the default. Start a polygon by adding several vertices. Notice that the shape remains closed, with the last vertex always connected to the first. Double-click on the last vertex to finish the sketch. Turn on Vertex Snapping on the Snapping toolbar. Change the construction method to Autocomplete Polygon. Click inside the existing polygon to start the sketch and snap to a vertex on the way out. Digitize the adjacent polygon. Snap to the vertex again on the way in, and double-click inside the polygon to finish the sketch. Begin a new sketch inside one of the polygons. Snap to a vertex on the way out, and digitize the adjacent polygon. Snap to another vertex on the way in, and double-click to finish the sketch. Use the polygon that's already selected, or select a different one with the Edit tool. Click on the Cut Polygons tool. Start outside the selected polygon and add a vertex. Digitize a line that goes across, and double-click on the other side. The polygon will be split in half. Check that the two polygons are still selected, and if not, select them with the Edit tool. Sketch another line that goes through both, starting outside, going through the middle, and finish outside by double-clicking. The two polygons are split into 4. Click on the Edit tool. Click and drag a box that goes around or through the practice polygon so that they're all selected. Press the Delete key. Zoom to the full extent of the map. Click on the Zoom In tool and zoom into these pink and purple polygons shown here. Click on the Geology template. Start digitizing around polygon A. Be reasonably careful, but it doesn't have to be perfect. Double-click when you get to the end to finish the sketch. In the Attributes window, type KKD into the Unit field and click Tab. In the Table of Contents, click on the Geology symbol to open the symbol selector. Scroll down and find the 10% crosshatch symbol. Click to select it and click OK. Double-click the Geology layer name to open its properties. Click on the Labels tab. Check the box to label features in this layer and set the label field to Unit. Change the text symbol font size to 12 and make it bold. Click OK. Turn on Edge Snapping on the Snapping toolbar. Click on the Autocomplete Polygon tool. Start by snapping to the upper right vertex of polygon A. Click along the fault until the purple area ends, and then follow the geologic contact around. The video will skip ahead. Click along the lower fault And finally snap the last vertex to the vertex of polygon A. Double-click to finish the sketch. Click in the unit box of the Attributes window and type KKBN for the unit. Click Tab. Click on the Autocomplete Polygon tool again. Snap to the corner vertex of polygon A and begin digitizing the C polygon. Follow it all the way around. The video will skip. When you get to the end, be careful not to snap to anything before you're ready. Snap to a vertex or edge of polygon B, and then double-click inside polygon B to finish the sketch. Click in the Unit window in the Attributes window and enter the unit name KKD. Click Tab. Still using the Autocomplete Polygon tool, start trying to digitize the purple slice below polygon C. As you go, you will find that it keeps trying to snap. You will need to adjust the settings so that you can digitize this. Right-click near the sketch and choose Delete Sketch. Zoom and pan so that polygon C and D fill the entire screen. From the Editor toolbar, choose Editor, Snapping, and Options. Change the tolerance from 10 pixels to 5 pixels and click OK. Click the Autocomplete Polygon tool again and begin digitizing, first snapping to a vertex of the pink polygon. Keep the unit narrow and thin and don't let it cross over. The video will skip. Continue on around until you get to the fault, and then head back and snap to a vertex of the other purple polygon. Double-click to finish the sketch. Enter the unit name KKBN in the Attributes window and click Tab. Click on the Pan tool and pan up so that you can see the long, thin slice of the fault up above. Click on the Autocomplete Polygon tool. Snap to the upper right corner of the purple polygon and digitize around the fault, and then around the rest of the slice. Enclose the entire slice and then snap back to the edge or vertex of polygon A, that's the pink one. While the sliver is still highlighted, click the Cut Polygons tool on the Editor toolbar. Digitize across the sliver on the fault, starting and ending outside the polygon. Double-click to finish the sketch and cut the polygon in two. This sliver is still selected. Digitize across it again to follow the other contact. Double-click outside to finish the sketch. Click on the Edit tool. Click on one of the brown polygons, then hold down the Shift key and click on the other to select them both. In the Attributes window, click on the Geology entry at the top, and then in the Unit field type KGRU for the unit name. Click Tab. Click on the middle unit to select it, and click in the Unit field and enter its unit KKBN, and click Tab. Pan or zoom if necessary to see the purple polygon below the sliver. Switch to the Autocomplete Polygon tool. Snap to the corner of the purple polygon on the other side and digitize your way around the polygon. Click inside the other brown polygon to finish the sketch, and enter the attribute in the attribute window, KKBN. Click Tab. Pan or zoom if needed to see the large brown KGRU polygon. Click on the Autocomplete Polygon tool. Start by snapping to the existing end on the lower fault and digitize your way around. Be sure to snap to a vertex at the other end when you get there, and double-click to finish the sketch. Enter the attribute in the attribute window, KGRU, and press Tab. Click the Edit tool on the Editor toolbar and select the purple polygon. Choose Editor, Clip from the Editor toolbar. Fill the button to discard the area that intersects and click OK. It will not appear any different, but the overlapping area has been removed. Now we will digitize these last two polygons. You may want to zoom in so that you can see them better. Click on the Autocomplete Polygon tool and digitize the purple one first. Start inside the brown polygon and digitize across the fault. Cross over it again and double-click to finish the sketch. Enter KKBN for the unit and press Tab. Still using the Autocomplete tool, close off the last brown section, snapping to the purple polygon on either side. Double-click to finish the sketch. In the Attributes window, enter the unit KGRU and click Tab. Right-click the geology layer and choose Zoom to Layer. Then zoom into the polygons that you just created. Choose Editor, Stop Editing. You will be prompted to save your edits, so click Yes. Then save the map document by clicking the Save button. Open the Catalog tab and navigate to the Austin folder. Right-click the Crestview Geodatabase and choose New Feature Class. Enter Buildings as the name of the feature class and leave the type set to Polygon Features. Click Next. For the coordinate system, choose the Texas State Plane from the Favorites folder and click Next. Accept the default XY tolerance and resolution and click Next. Now we will add some fields. Click in the first blank field name box and enter the name BLDG type for building type. Click in the data type box and change the type to text. Click in the length box below and give it a length of 25 characters. Click in the next empty field box and enter the name address. Click in data type to make it a text field and leave the length set to 50 characters. Click in the next empty field name box and enter the name city. Change it to a text field and set the length to 25 characters. Click in the default value box above the length box and enter Austin. Click in the next available field name box and create a field called State. Set it to a text field and give it a length of 2 characters. Click on the default value box and enter the default value TX for the state abbreviation. These are all the fields you need, so click Finish. The new feature class appears in the table of contents. Click on the Zoom In tool and zoom into this large block of buildings in the southern part of the study area. Choose Editor, Start Editing. Right-click the building's template in the Create Features window and choose Properties. Examine the template settings. Note in particular the default tool, the drawing symbol, and the fact that the city and the state are already entered into the fields because you set them as default values. When you're done looking at it, click Cancel to exit without making any changes. On the Editor toolbar, click the Attributes Window button, and if necessary, dock the Attributes window beneath the table of contents. Click on the building's template. Start with the corner of the first large building on the left and digitize around it. Double-click to finish the sketch. In the Attributes window, enter Commercial for the building type. Notice that Austin and Texas are already entered. Digitize the next building to the right also. And double-click to finish the sketch. Enter its building type as Commercial also, and press Tab. Right-click the building's template in the Create Features window and choose Properties. Change the name of the template to Commercial. Then enter the text Commercial in the building type field and click OK. Click on the Polygon tool if necessary and digitize the next building to the right. Notice that the Commercial attribute is already entered for the building type. Right-click the Commercial template and choose Copy. Then right-click the copy of Commercial and choose Properties. Change the template name to Residential. And then enter Residential in the building type field. Click OK. Click the Residential template and digitize one of the smaller residential buildings above the commercial ones. Double-click to finish the sketch. In the table of contents, right-click the building's layer and choose Properties. Click on the Symbology tab. Choose Categories, Unique Values for the map type, and enter Building Type as the value field. Choose a color ramp and click Add All Values. Click OK. Now the two building types are shown with different colors. Save the map document so it will remember your new templates. Zoom or pan if necessary to put several more commercial buildings in view. Click on the commercial template. Enter 2 vertices defining one edge of the building. Click the first drop-down button on the editor toolbar and select the right angle tool. Enter the vertex on the 3rd corner of the building. It will be constrained to be at a right angle. Continue adding the corners until you get to the last one. Then, instead of entering the last one, right-click on the spot and choose Square and Finish. Continue digitizing the rest of the commercial buildings until you reach the end of the block. Use pan or zoom as needed to keep going to new buildings. Zoom and pan if needed to show some of the residential buildings. Click the residential template. Select the right angle tool again. Digitize one of the houses in the block. Choose right-click and Square and Finish. Continue digitizing all of the houses in this block. After you finish digitizing the last house, choose Editor, Save Edits. Find the address points layer in the table of contents and double-click it to open its properties. Click the Labels tab. Check to label features in the layer. Make sure that it's using the full name field and make the symbols Arial 10 point. Click the Symbol button. Then click the Edit Symbol button and click on the Mask tab. Fill in the button for the halo and click OK and OK and OK to finish setting the labels. Scroll down and find the Buildings layer. Right-click the Buildings layer and choose Selection. Make this the only selectable layer. Click the Edit tool on the Editor toolbar and select the 3 buildings with the address on Isabel Drive. In the Attributes window, click on the Buildings entry at the top so that the edits are applied to all 3 selected buildings. Click the Caps Lock key on your computer and click inside the address field. Enter XX Isabel Drive in the address field. That places the street name in all 3 buildings, so all we have to do now is edit the address. Click on the first record in the Attributes window. The building will flash so that you can see which address it needs. Double-click the XX and enter the address. Then select the next building. When it flashes, find the text. You may need to refresh the screen. Enter this number. Include a space and press Tab. Click on the 3rd one and enter the same address as the house, 6629. Now all 3 houses have their numbers and addresses. Pan, if necessary, to the next group of buildings in the block. Click on the Edit tool. Clear the selection. and then select the next group of buildings. Click on the building's entry at the top. Click in the address field and type XX Esther Drive. Click on the first residential building and examine its address. Edit the X's and type it in. Click on the next one and enter its address. Click on the next building and enter its address. Click on the final building and enter its address. Right-click the building's layer in the table of contents or in the Attributes window. Choose Open Attribute Table. Examine the fields for the buildings. Notice how much information is already set. Close the table when you're done looking at it. Choose Editor, Save Edits. Then click the Save button to save the map document as well. Choose Editor, Stop Editing to conclude the edit session for now.